Okay, continuing on with lesson 3.5. Here's a problem situation. We go back to looking at two variables, and those variables we're going to call explanatory or response, or independent, dependent. So for example, in this situation here, the goal of this information we have here is to explore the relationship between a driver's age and the maximum distance at which signs are legible. So the course thinking that the younger you are, you can see further. And so data was collected with age and how far someone can see. And so when we collect data and have data with two variables, we want to study those. And the way we study them and find relationships is to make a graph of them, or something that's called a scatter plot. And so here's your example of a scatter plots. Here's driver 1, driver 2. You can see where the numbers are. You can see how they're plotted. And you don't get a perfect line, but you can see that there's some pattern or some relationship here. Once we see it kind of in this sense here, what we're looking at is we say is that we think there's an association between those two variables. And the way we would study that is through linear equations, because it kind of going in a linear pattern or some line pattern, like it's coming down in that direction there. And so our first activity is to kind of look at the relationship. Again, this is made up data, but look at the relationship between English scores and history scores of two students. These are 5th grade students who took a test. And so when looking at the relationships, we would go ahead and plot the points. You would go ahead and label that so that you could plot these accurately, and they'll have some kind of shape like that. Now, what I want to do is to plot those points, we want to use Desmos. So I want to show you what that would look like on this video here. So you would go ahead and open up a Desmos page. And so what would happen is, let me get you to the beginning there, is that you would have, what we're looking at is, you would want to make a table of values of the information from here. So we take this information and we make a table of values in here. And the way you do that is you would insert a table. After you insert the table, you would get a blank table after you go to desmos.com, of course, and you enter that data. So take a minute to do that. And you just type it in as you go in there. You type in that data from this table here. And as you do that, what will happen is those points will be plotted here. And if you look carefully, I can't see them here, but the values are only from like 4, -6, 6. So what you do is, I'm going to zoom out, and then as you zoom out, you can see, fool around, you can see there's the points, and I kind of just scatter plotted those there. And so you would then, after you have those plotted, you then ask yourself, is there a relationship between them? And it looks like as our, let me get back down there, as the English scores were increasing, looks like their history scores also increase, which means that there's probably some relationship. And so how would we describe it as a formal language? I would say there's a strong positive relationship between these variables, right? Two students with higher English tend to have higher history scores, and that would be the relationship. Now, we're not going to do it by hand. The instructions say to do this by hand. What we want to do this is with Desmos. And so in order to do that, right, instead of finding the equation by hand like we were doing here, we have the computer do that for us. We did it here just to remind us of the work. And so what's going to happen here is, once you have that in there, we want Desmos to find the equation of this line. And so here's the instructions here that you would be plugging in. And so again, I'm going to retype that and reproduce it, but it's going to end up looking like that. And in order to do that, you would say y1, and then type y for the equation, and then a 1 right after. Or what you do is you got to use the little sub right here, that one, y1. Arrow over, and then you got to use this symbol here, and then you click that, and so by typing these commands, what you're doing is you're asking the computer or Desmos to find the line that of best fit, or the least squares equation line. You can see it goes to the point. So what we did by hand on the warm-up, the computer is doing for us right here. And so notice what you see is I see some values. I see the equation line, and the computer gives you some values. And so thinking about how history score X and Y, you would see you end up with this equation here, what's called the least squares equation. Notice where those numbers come from, and here where those numbers are. Your numbers are coming up here. We'll revisit that right now. This is called the least squares line, and again, you can read why it's called. We don't worry about that until statistics. Here was the instructions that I kind of walked you through, and this is the equation right here that we end up with. This is what you end up with Desmos. The X value represents the English score, which is the X-axis. Your Y is your history score. And so notice I get those values from these, what's called parameters there. We would then use those to then answer questions about the relationship between English scores and history scores. And so looking at that here, we can then go ahead and answer some questions. So using the equation we got here, predict the history score, which is the Y value. For someone with an English score of 53, you would substitute it in. And so that's where you'd get your answer from. And that's how we would use a least squares equation, right? Least squares regression line to make a prediction. We'll continue on with what this means in the next videos.